we will move to our second speaker, who is Mr. Mr. Farai, actually, who will deliver another talk. Wait, please. Okay. Yeah, so Mr. Farai Mazhandu, he's the president actually of OneQuantum Africa, another initiative with aiming to actually promote quantum across Africa, and he will deliver actually a talk about moving quantum forward in Africa. Please welcome, join me to welcome Mr. Farai. Yeah, back to you, Mr. Farai. Okay. Let me please make you as a co-host so you can actually
Yes, Hassan, how are you?
Yeah, I'm doing well. Thank you. How are you doing?
Much better. Thank you very much for the opportunity to come and share. Really,
Thank you for
really
joining us.
appreciate it.
Definitely.
So let me share my screen. I hope this works out. Okay. So here we go. I guess you have my screen now.
Yes, sir. Thank you.
Sure. Thank you. Thank you very much, Hassan. Thank you, Abdallah. Thank you to the team at Q Morocco for putting together this beautiful program. It's really a pleasure to be able to come on and to share. Really appreciate it. So generally, let me say brief remarks about myself. I'm an entrepreneur. I'm a scientist. I'm a community builder. I do data and I do training and all these other things. So quantum technologies has been a very interesting space for me. And it came up because once in a while, I always challenge myself to join a new field, and a new field where there is room to make contribution, meaningful contributions, I should say, a new field that allows new ideas to flow, that is, that just opens different roles for all people who are interested to come in and contribute. So this has been Quantum Tech for me. So yes, I'm the president for OneQuantum Africa, which is a chapter of OneQuantum, the global community that brings people together to collaborate, to learn, to exchange, to get mentorship, to work on projects that are relevant to their local communities, and to just make people come together so that they're able to speak with one voice. It could be to move the conversation forward. It could be to shape how the technology is evolving. And it could be to reach out to vendors and other suppliers in the industry, to even the ground, to foster collaboration or anything else that can support community objectives. I'm also a co-founder and CEO at Biotech Quantum Technologies, which is a startup out of Johannesburg in South Africa. And we also have offices in Zimbabwe, which is where I'm joining you from. I come in there as well because I've got an MSc in physics. I worked in a nanoscale transport lab, perhaps something similar to what Najma was sharing on. So I worked on the synthesis and the testing and fabrication of devices, very small devices that are based on these aspects of quantum technologies. And this is where I started getting involved in quantum. So I was also fortunate that I was able to, let me go to the next slide. I was able to work on the IBM Q Platform and do some simulations. And as some of you may be aware of, quantum computing was born out of the need to simulate nature. So this becomes more of a natural ground for fields like condensed metaphysics, where you are trying to look at the behavior of the very small and look at what happens when at interaction levels in matter at a very small scale. So I worked on the IBM Q platform to do a simulation protocol of a hybrid quantum system. I think Najwa shared the different platforms that are being pursued, and there's unlimited scope in that space. You can use carbon nanotubes, you can use trapped ions, superconducting qubits, photonics. Some are using light, optical light, and NFV centers in diamond. So there are a lot of possibilities. So we were looking at a system that was based on NFV centers in diamond and how you could combine their best features with the flux qubits, which are a variation of where we get transmon qubits as well, which are the ones that are used mainly for superconducting qubits at Google, as well as at IBM. So I did that work. I did that. I was at the University of Wits in South Africa, and so because of this exposure back then, there wasn't a community. We were a small community, and we were not as connected. There are people who have been working in this space in Africa in other research centers, but I was not aware of them. And even to research in terms of resources, you needed to use YouTube videos and to scrounge for whatever you could find on the internet. The field wasn't as developed as we see it now. So it was really a lonely space. But things kind of changed when IBM and WITS-Q, or WITS, came together to build WITS-Q, an initiative that ended up feeding into the Arua network of universities to give access to quantum computers on the cloud. And so the summer school was hosted to try and advance that. And then a QSKIT camp hackathon was also hosted in South Africa. So this brought together enthusiasts and people who were interested in the space in Africa to come together and work on problems. So that was a very interesting opportunity to start connecting with the community in Africa as well as the global community. And ever since then, things have been happening. We've seen the world coming more closely together. Obviously, on the backdrop of COVID-19 and this work from home, flex work, and the ability for people to work remotely and collaborate, there's been a lot of traction that we have seen happening in the quantum tech ecosystem, and I guess in every other industry in general, in terms of the need to collaborate and to work online and to work from wherever you are. So you see me here in high school with my headmaster at a leavers party, a leavers dinner. I guess in most of these countries, it's more of a tradition that as you leave high school and get into the next phase of life, there's a big event where you come together, share ideas. People begin to teach you about how to transition into the real world as it would be. You see me here on a multi-deposition chamber in one of the clean rooms at the nanoscale transport lab at WITS in South Africa. And from there, because some of the work that I was doing in MSc, which was based on devices on diamond, NV centers in diamond, and heavily boron-doped diamond, and both these variations have got interesting behavior at low temperature and high fields, which could be used for devices for quantum technologies. And I worked in that space. So because of the work that we were doing, because we're looking at a new hardware platform or a different hardware platform, it was exciting to integrate this to QSKIT. And I think you have seen companies like IonQ coming on the QSKIT platform. I think Code Quanda also bringing their platform to QSKIT. So this has always been the idea, perhaps from IBM, to say perhaps QSKIT could be used to connect to other hardware platforms, which are not only superconducting qubits. So I was working on an NV center type of hardware. So we were also exploring how we could use QSKIT to connect to that. And because of that work, our team came second place at the hackathon. And of course, COVID happened. There was a freeze on movement and events, physical events. I ended up participating on building a community with open source because it's something that I can really relate to. It even allowed me to do the publications that you see me sharing on this slide, and to also contribute to the way that this technology is unfolding from Africa. It was never something that I imagined could be possible when I started in this field. But as fate will have it, we are now all talking about this now from where we are, and we are seeing these opportunities to collaborate, getting more realistic each and every day. So recently, I'm just trying to show you the path that I followed. So after being a panelist and building a community with open source, which was the IBM Quantum Summit in 2020, I was also recognized as a quantum leader in Africa by IBM. And recently, I was also featured as a panelist at the Inside Quantum Technology New York event that was held on May 17 to 20. And we were discussing building a quantum competent workforce. And this is a very important conversation for Africa because we have a lot of young people, and the young people have energy, which is a given. And we need to harness that energy to give them skills. And now with this ability to work from home and to contribute from the continent, I guess you relate with this, that there are a number of people who have been able to get opportunities to work internationally from Africa today. So this is becoming more and more realistic. So there's need to give our people in the continent skills so that they are able to contribute to the development of the local communities and to also compete globally, because we have a lot of young people and we are likely to be contributing significantly in the workforce of the future. And on this panel, Dr. Araceli Gomez, I think she shared on what they are seeing, because they scope this whole HR space, that young people, that's your high school and perhaps early undergrads, they've got a huge opportunity of, when they get into industry, this is when quantum technologies are likely to be fully mature and, really creating impact, and there will be a lot of jobs and opportunities to take forward. So the conversation that brings me here and that is close to my heart is a conversation of growing quantum in Africa. And I'm really happy to be here, especially on Morocco Quantum Day, and just the framing of it all is something impressive. So well done to the team, and congratulations to everyone who put their effort together to make this happen. These are important conversations. We need to build strong local communities in Africa, and then connect those local communities to build a very strong continental effort, and also connect with the global community to stay abreast of the latest developments, to contribute at the highest level, as it would be to learn about the trends as they unfold, to shape the industry and influence how this whole quantum tech ecosystem unfolds. And you will understand why as I share my next slide. So Fortune, we carried an article in June 2019 where there was this quote that goes, perhaps no other emerging technology spans so many different disciplines with so many potential applications. And from Najwa's presentation, you could tell, I think she did a very good job of covering all the areas which apply. And there was a question on quantum technology as well. So what we are only talking about here, we are saying this ability to now harness the fundamental properties of nature, or at the very small scale where the laws of quantum physics or quantum mechanics take off, allow us new capabilities in sensing information, in processing information, in the communication of information, which allows us to do things at the next level from where we are. A very simple example would be, I was looking at the trains, when you look at what has been happening at Intel as they made the chipsets. I think they last made a chipset, a unique chipset that could be around 2005, 2006. And all along, they've been integrating these and bringing them together to make one powerful processor. And this is why they are called cores. And you see now, I think we are at a point where even AMD with their Ryzen family of processors, they are able to pack almost 40 billion transistors in that chip. But we can't always, we are getting to the limit, where silicon is under pressure. You can't continue extending this computational speed that way. Of course, IBM recently unveiled 2-nanometer semiconductor chipset, which could change the game, allowing us to move on in terms of saving our batteries on the mobile phones and more processing power, looking at what is happening with edge computing and all the other things that could happen. But those limits are showing us that we are going to end up with having a transistor which is an electron which is very small. And when we get into that space, we are moving into the realm of quantum mechanics and quantum physics. New laws take over, and our thinking has to shift as well. So it is important for people who are interested in technology to also shift their thinking and to get to that level, because that is the next level. Right, so this is where we are. This is our opportunity. Because I love data, data advises us. It tells us exactly where we are and what needs to happen. So through my work at Interference Advisors and Biotech Quantum Technologies, which is a startup out of Africa, which focuses on consulting, data, and training, we scoped the quantum tech ecosystem to just look at the quantum tech leaders who are founders, CEOs, heads, vice presidents, you name it, to just look at the demographics of these people. Where do they come from? Which are part of society? Which countries, etc. And we even looked at which institutions they come from, but I have not shared it on this slide. But you will see a glaring difference between the Caucasian a part of this community and African American and others. And that shows you that that is our opportunity. We need to step up. We need to come in there. As I was doing my MSc, my vision for the field was I didn't see anybody who was like me in quantum, and I still don't see so many. And my vision is to end up in a day where our young people in Africa can look at somebody who is a thought leader, who is a leader in quantum, whom they can relate to, who is of African origin, who's raised from the same society. And that is something that we have to change. And I think we can do it, not because the world is going to give it to us on silver platter, or the standards are going to be reviewed for us to be able to make it. I think we've got very good talent in the continent. We are very capable. And I want us to prove and claim our place as Africa, because we are also good enough. And this is why I've been contributing to the community from here. And I think I want those contributions to stand out, not because of the color of my skin or where I'm doing it from. I want those ideas to stand out because they are good enough, and they change the field, they shape the field, they allow us to move to the next level. So this is our opportunity as a continent. And this is why we need to talk about moving quantum forward in Africa. Let's look at the quantum tech ecosystem global overview to just look at the kind of public funding that has been getting into the space. You'll see in excess of $32 billion US from what we can track and verify. And of interest, I just took these snapshots of recent news coverage from China, where Shenzhen is looking to invest US 108 billion in research and development over the next 5 years. And all this is being done to also include technologies like quantum computing. So it means quantum computing is a very important industry, which is going to be able to bring new pockets of growth to allow even China to keep on growing their economy. And it's also the same opportunity for all of us anyway. Joe Biden's administration unveiled 180 billion research and development, and we see there, this was from Forbes, we see that investment is earmarked for chips and quantum computing. So it's very important that we also pay attention to this and we begin to develop competencies in this space in Africa. Right, let's look at the next slide. Najwa did a very good job. I think she shared some of the companies that are working in the space. I will not repeat what she talked about. What I want to say here is you realize the usual companies that we are aware of: Microsoft, IBM, Honeywell, Google, Alibaba, Intel, taking an interest in quantum technology. building quantum hardware to allow us to move to the next level as it would be. And what that means is they've been giving us products and services over the years, and they are transforming, so we can't be left behind. And the good thing about how quantum technologies are evolving is we have got an opportunity once again to start, with everybody else. We can't always be left behind and end up being consumers and using this technology only on the margins, as I'll say. We want to contribute to how it is unfolding today. We have got that capacity, and like what we saw with what happened with COVID, it kind of brought in a new model of working where people can work online. And the good thing about it is that was already happening because there was this availability of quantum computers on the cloud. Open access seems to be more like a model that is going to be sustained for the foreseeable future. Communities are coming into place. The field is just open, and people are generous. You are joining this session. It's for free. You come in here. You can connect with people who are interested in the same things. There are also experts who have been brought forward to come and speak to all of us. So we get to learn from the people who are involved in this work each and every day, and it allows us to figure out how we can contribute. So I think we want to make use of that opportunity. And take advantage of that. We also got this from the previous presentations on industries where quantum technology shows promise. I just want to highlight some of the companies that are looking or considering these technologies and looking at where they can deliver value. You've got companies like BASF. I want you to just realize that some these companies making chemicals and making materials already. So they are paying attention to this. This can help you to figure out what role you can play, because you may be involved in chemistry, you may be involved in engineering, you may be involved in petroleum or in any industry that you are in. So it's good when we share some of the names that are considering quantum, so you can also figure out where you can come in and have a role to play. Companies like Biogen, Bayer, DuPont, some of them make agricultural, they make fertilizers, they make chemicals that help us in agriculture, in resources as well. And Africa is very rich with an array of natural resources. So we need to pay attention to that. In logistics, companies like VW, these already have assembly plants in Africa. I think they recently opened a plant in Rwanda. And they're introducing electric vehicles. Those need batteries that take away range anxiety so that the cars go further. And all those improvements in materials design are things that are important that we all need to pay attention to. Companies like Airbus, BMW, NASA, Bosch, in terms of quantum sensing, Daimler, in IT, IBM, Alibaba, Google, Samsung. I think that's obvious. Samsung recently unveiled, I think, the second generation of a phone that has got a quantum random number generator in it. And those are all the developments that we're seeing. So that technology is coming closer and closer to us. And for some of you who are going to buy 5G, Samsung 5G phones, you may be holding a device that has got some aspect of quantum technology already in it. JP Morgan, Barclays, Goldman Sachs, ING, amongst others. There are actually many players and many partnerships that are coming together in the space. So I just did a framing there of some of the applications that you can see. And I have to skip that because I already talked about that. So let's talk about what has been happening in Africa. We recently hosted a summit in Africa, which brought together quantum tech leaders from the continent to come and, we wanted to just popularize quantum tech so that people know what it is and what role it can play. We also, excuse me, I'm just trying to check for in terms of what I'm doing, how I'm doing in terms of time. We also wanted to, so there was an opportunity to educate the continent about quantum technologies. We also realized that most of the efforts happening in the continent are fragmented. There are people who are working in the field who don't know each other, who don't collaborate, and we are not so much aware of what's happening. And it was good to bring all these researchers that we had access to, that we could reach, to come together and just begin to share where we are and what we need to expect, and what could be the next steps that the continent needs to take, so that everybody understands where we are. So we've got a second summit coming October 13 and 14, and we'll reach out to a new set of speakers from the continent, because there are so many, and we want to continue learning about what's happening. We want everyone in the continent to know where we are and where the opportunities lie. So I was sharing here just a slide on that summit, very successful, well attended. More than 350 people came through. We were supported by one of the international players in quantum hardware, Honeywell. We thank them so much. A good stand-up partner for us, but we look forward to having more companies in Africa realizing this opportunity and also supporting the growth of communities in Africa, because it is in their interest to build those capabilities in the continent. We need to get to a point where we have got this technological sovereignty, where we have got our own people who have got the best skills, who are exposed to the highest level, so that they can also solve problems that are very important to us in the continent. They are going to drive a value in the organizations in Africa. So it is of interest for organizations in Africa to support the growth of these communities like OneQuantum Africa, the Q cousins that are taking shape in the continent, and any other effort that is just bringing people together and moving this conversation forward. These are just the metrics of the event, and I will not waste time on them. And so I want to share this slide, which are the keys for progress, to just show you the amount of work that is available, where each and every one of us can contribute, no matter where you are from and which background you are from. So there's need at the moment to verify whether the devices are performing as expected, especially quantum computers. They're available on the cloud. So there's need to benchmark them, for example. So that takes anybody who is really interested and who wants to learn about the technology and there's got internet connection and can jump on a cloud platform. So there's that need for validating the devices that are there. There's that need to develop algorithms, to work on software, to work on integration, because quantum computers are not going to work as standalone devices. They work in a hybrid model, I want to presume, where there are aspects of classical technology that are always going to be part of quantum technologies. Even to this day, the way we read results from them and represent those results is already a classical method. So it is very important that a number of people come together. Somebody was asking, they're an engineer, and then they were asking about quantum technologies, what role they can play. And I think Najwa was very good answering in terms of, she said that there is room for everyone to come and contribute. You could work on the component side to support the hardware, depending on what it is. Other people have been in electrical engineering. Other people have been using microwaves for other things, and microwaves are used to communicate with these devices and to read them out. And you may want to start learning about that, cryogenics. These have always been part of our cold chains and cold systems, low temperature experiments that we have always been doing, and we're simply going lower, and it's still the same aspect. We are just simply getting into a new pathway of technologies. But I always want to emphasize and say, it's whilst the fundamentals of how these technologies work are new compared to what we have been using classically. The underlying or support systems remain the same. We simply have to optimize them for devices like that. So there are many roles. I made this slide very busy to also demonstrate that there are many roles to play. And I won't repeat and read what's the text, but I guess you get the idea. So we looked at quantum technologies in Africa, because the other question will always be, people are going to say, are we not being too forward in Africa and trying to punch above our weight? Perhaps we've got other problems to look at, and quantum tech is a bit far off. Let people who have always been leading in these spaces do it, and we simply come in when the technology is right. Excuse me. And then I want to say we have a role to play. And we see startups in Africa raising record amount of capital. We see them using AI and complex optimization techniques. And for them to keep on being competitive and delivering improvements in terms of returns, in terms of optimization, in terms of efficiencies, they will need to consider technologies that may be inspired by quantum techniques or something like quantum machine learning, or anything really, because when people are educated about technology, they get creative enough to solve problems that are relevant to what they are looking at. So this is exactly what you want to do. You can't prescribe what people are going to do with technology. Our responsibility is to educate society about the possibilities and give access. So we want to fight and make sure that everybody who is interested and active has got access. And when that happens, it is entirely a matter of creativity in terms of what are you going to build and do with the technology. So that is our opportunity. Fortunately, in the interest of time, I may have to move a bit fast. So I was just looking at the Africa we want from the how it's framed by the AU and NEPAD framework. And you realize that issues to do with collaboration stand out. So it is now, and COVID has accelerated that realization. We need to come together, to work together so that we solve problems that are challenging in the continent. We can't do that in a fragmented way. So there's need to come together. And I'm happy at governmental level, at the AU, these are things that are realized, and these are things that are being talked about. So let's collaborate, let's work together, let's build strong local communities where we expose people to these technologies, support them to grow, link them with the global community so that they learn about the best practices, the standards, best standards, they begin to contribute and influence conversations and how this technology is unfolding. This is our moment for Africa to not stay marginalized from the international community. And all these conversations we are having are helping that effort. People notice that Africa is contributing. Africans are coming together. They are talking about this, and they are also contributing. We also celebrate our local heroes in the field, and we make this opportunity real for young people who also want to contribute, because they realize that somebody like me from my environment has been able to contribute to this new technology, and it means I can also do it. And that is very important for the future workforce. Like I said, we've got a lot of young people, and it is even good for the world. Some solutions can come from Africa and also go to help across the world. That is possible. It is not a dream that is far off. At OneQuantum, we have tried to do this we affirm what we do in terms of communities, local communities in Africa, make them very strong, connect them to the global community. And the other thing that we look at is mentoring. So we have partnered with Keysight Technologies to bring a platform called MentorClick, allowing people in the continent to connect with experts, to be mentored so that they learn and also transition in the best way to a career in quantum. We also have got a careers aspect where we look at the training needs in the continent. The first thing that we need people with skills who understand what quantum tech is and can work on quantum technologies, so that they understand what it is and they can do something on it. On quantum computers, they can integrate quantum hardware or quantum sensors or quantum key distribution devices into our ecosystem. Then from there, we are going to begin to look at whether can we build that technology in our local environment, and can we build a quantum computer for Africa. Those are far off goals, but I think what is important is to train people and give them skills. Whatever comes next is entirely, a matter of creativity. We also work on projects, bring people together, have a project leader from the continent who is a leading expert. That leading expert is also seated with an international expert in the field to benchmark, so that we are also at the highest level of this tech. And we work on projects that are relevant to the continent. It could be drug discovery, it could be optimization problems, whatever we can imagine, which is important for problems that are challenging for the continent. So quickly, we are also having a Q cousin, or on a process to have a Q cousin in Zimbabwe, to build a strong local community in Zimbabwe as well. We need your support, and I just thought I could share it here. And we are inspired by Q Morocco and others. We have taken the lead, and this is the reason why we need these real opportunities for young people to get educated in this space. You can connect with me, find more details about our effort at OneQuantum Africa on these links. You can send me an email. I think I shared a slide that had my email. My screen is being a bit funny, and I can't see some of the things clearly. So I'm just trying to use my memory of the slides that I'm sharing. But all the same, I think we are on a slide where you can see details about how to learn more about the efforts that we are making in Africa. This is how you can get in touch with me. We can keep the conversation going and figure out how best we can support each other, support our young people, make society learn more about quantum technologies. Have got a society, build a society which is confident in a world where technology is always changing things for us each and every day. And that is the first. So when we have that confident society around us, which understand the role of quantum technologies in terms of impact, detrimental effects, positive impact, then we can begin thinking about how are we going to use the technology to solve our problems. And I think we have that ecosystem naturally that supports that. There are a lot of brilliant young minds. There are a lot of brilliant people in Africa who can figure this out. We just need to work together, find ways of collaborating, learning and exchanging together. I'm not sure if I've got a next slide here, but I think this is all that I had for you. Thank you very much for the opportunity. And I'm sorry for stretching it a bit. I ended up flashing, so I couldn't be so fast.
All good, Farai. Yeah, thank you. We are on time. Yeah, thank you. Thank you again for this brilliant presentation, actually, and for all the efforts, to bring ahead quantum computing and to drive this adoption. And yeah, that was brilliant. Thank you very much. We have a couple of questions actually from the audience. First question actually is from Paida Mozamba. Thank you for the presentation, Farai. I'm a mental health advocate and aspiring to study clinical psychology and neuropsychology. How do you think quantum technology can be applied? I know general knowledge about computer science, so please, when you use jargon, could you explain? Thanks.
Okay, thank you, Paida, for such an important question. Hoping that I can answer it. But in terms of the role that quantum technologies can play in health in general, I'm not an expert in your field in particular, so I'm going to talk about health broadly. We see improvement in sensing. For example, your MRI techniques can be improved through enhanced sensing, enhanced sensing. So that allows the diagnosis process to be much more informative for health practitioners. Also, I had an opportunity of working in a radiotherapy department, and the treatment planning, where you're planning treatment of a patient, is a very important part of that scheme. And optimizing such a procedure requires handling a lot of variables, and this is where quantum computing comes in as well. It allows us to deal with multivariate problems in a very practical way, and that enhances the kind of solutions that we can provide. Also, given that quantum computers try to derive their capabilities from nature, so there's this aspect which is also even being fed into quantum machine learning on neural networks, where we're trying to look at how the brain operates. So that understanding of the operation of the brain is something that could be simulated, or that we can try to understand using quantum devices or using quantum computers. So those are some areas that you may want to look at. There could be a lot more other things that I've missed, but at a high level, those are some of the things where we're seeing the impact of these technologies in health quickly.
Perfect. Thank you, Farai. Another question actually from Osama, who was asking, are you aware of any funding organization for research in quantum technologies in Africa?
Perhaps not for quantum technologies, because at the moment, I haven't come across anything dedicated. There are groups, that are focusing on quantum computing. For example, the Alexandria Quantum Computing Group in Egypt. I know in Tunisia, the University of Tunis, Oman, I think Professor Morad Domini is going to unpack that. They've got a nanotechnology aspect to it. The University of KwaZulu-Natal has got a Center of Quantum Technologies. FITS is starting to introduce quantum as well. But what is happening with quantum technologies? There are always areas that have been there, like optics. So they are, and you are, these people have been studying the behavior of matter at the lowest level. So I don't know whether to say funding that has gone into those efforts has also been going into quantum tech in some way. So this is the kind of funding we can cater for. Your organizations like the NRIF in South Africa, the CSIR, and many other leading supporters of research in Africa have already been funding nanotechnology, photonics, lasers, and many other aspects of research which could be related to quantum technologies in one way or another. So that could be the funding at the moment we can allocate to quantum, but there isn't anything that I'm aware of that is strictly for quantum. Perhaps we will see that happening in the near future.
Okay. Yeah, brilliant. Well, again, I can bring some key points about that. Maybe in Africa, we don't have such funding because we are still we don't have some adoption or some interest from hedge funds in Africa. But here in Europe, for example, we start seeing a lot of hedge funds actually get interest in quantum computing. Especially here in France, we have a hedge fund called Continuation, who is specialized in quantum computing, and other classic traditional hedge funds start also to explore quantum computing opportunities and fund new startup and stuff. But I believe it will come. It will come soon to Africa. So yeah, sure. Another question from Najwa actually. He's asking about. It's actually a good question. He's asking about the possible opportunities in quantum in Africa, especially on the applied side, and also the strong need for having a community understand. Okay, sorry. The opportunities for government lobbying. I do believe this is a good point actually to drive adoption, government lobbying. And I'm thinking actually of Rwanda, for example, Paul Kagame. I do believe, I don't know, I hear he gave a talk, I don't know when I heard that, but he mentioned actually a quantum community plan maybe for Rwanda in the next coming year. So I don't know if you can bring some point about that.
Sure. Rwanda has been doing very well. They are open to new ideas and doing amazing things. They're building innovation hubs. They've got, I understand, Quantum Leap Africa, but I've seen them focusing on data science side of things, not purely quantum. Perhaps we'll see them showing that in the near future. Yeah, Rwanda is a very interesting place. Kenya, again, another one. South Africa, as part of their fourth industrial revolution commission, quantum gets mentioned here and there. So yes, there are people in government aware of where quantum is. But I think what we need to do, the way that I believe we need to do it when we're working with government, is to demonstrate something on our own. So this is why we're building a community and doing what we're doing. And we are not doing it because we quickly want government to fund us. Yes, government support is very important to move this field forward. But we think that when we wait for them to understand what's happening and they have to justify whether they think it's necessary to fund it, because they've got a lot of other problems to deal with as well. So what we want to do is to bring the community together, collaborate amongst ourselves, even given that we have got already access to leading researchers in the continent, figure out a way of just working on these things on our own and demonstrate the value, demonstrate that this is where we are going, and then justify that we need support to move forward. And I've seen that working. For example, after our summit at OneQuantum Africa, the OneQuantum Africa Summit, there are conversations we have started having with some of the major contributors of research who are part of government to say, okay, so what should we do? And where are the opportunities? What kind of support do you need, and also helping us in terms of what kind of a structure our communities should have in order to be optimized for government support. So I think that is a very important direction. So having more local communities and making more making this conversation about quantum more and more popular and making more noise about it, if I can say, is important to get the support that we will need as we go into the future.
Okay, thank you again, Farai. I mean, with that, we will close the Q&A session for this talk.